All right, let's look at some properties of linear functions. So the graph of a linear function is a straight line. That's something we've already mentioned, but I thought we'd put all of these properties kind of together in a box so we can keep track of them. The easiest way to graph a linear function is when the function is in slope-intercept form. So if people remember this from high school, this is usually the one thing they remember. And if you don't, that's totally fine too. But slope-intercept form is the function or the equation y equals mx plus b. So that will give us a linear line. The m represents our slope. And remember that slope is a constant rate of change. So there's no variable in our slope for a line. It's just a number all by its lonesome. It can be positive or negative or zero or even undefined. We'll talk about that in section 1.4. And the formula for this, so we're looking at the change in y over the change in x. So it would be y2 minus y1 over x2 minus x1. And that should look a lot like our average rate of change formula from section 1.2. So that's what that is. So that gives us the m. The m is the slope. The b is our commonly called the y-intercept or our vertical intercept. So I sketch a little graph here. It's where my function crosses over this vertical axis. So it's this point here. And that happens when x is equal to 0. So if I had the equation of a line, maybe y equals 8x minus 5, and I needed to find the y-intercept, well, I know that I'll get the y-intercept when x is equal to 0. So I can just plug that in, and I get y is 8 times 0 minus 5, which gives me that negative 5. So that's kind of how you can use that information. In a mathematical model, that letter B often represents the initial or starting value. Okay, and that's what we had up here. Our starting value was 8,000. And there's our 8,000 there. Okay. Now, sometimes that B doesn't really actually have any practical meaning or statistical significance. And that happens a lot in statistics with regression lines. If you take an intro to statistics class, you'll learn about regression lines. And so let me give you an example of where it doesn't actually work to say this is a starting value. So imagine a forensic pathologist or a forensic coroner type person has a set of bones. There is a formula that they can take the length of the femur, which is your large leg bone, and they can use that to predict the height of the person. Okay? So imagine this line here represents that. So maybe a person with a 50-inch femur is a little bit shy of 6 feet. Okay? So that seems all well and good. Here's our y-intercept over here. Okay, so there's that B. And so let's see, that looks like it's maybe at about 2 feet there. So the interpretation of this point is when your leg bone is 0 inches, you will be 2 feet tall. Now, does that make a lot of practical sense? If your leg bone is 0, so there's no leg bone, that you're going to be 2 feet tall? It doesn't make a lot of sense. So sometimes it doesn't actually have a real world application, but when it does, the real world application is usually that it's our starting value. All right, so let's give this a try. So turn to the next page of that classwork. We'll look at this example at the top. So Acme Hardware Manufacturing Company has purchased a new drill press for $17,000. If it depreciates $500 each year, find the following. So this word depreciates, if you're not familiar with that, it means it loses value. So think if you buy a new car, each year you have the car, it kind of goes down in cost or down in price or how much you could get for it if you were to sell it. Okay, so we have something that is going downhill, right? Because the prices is getting less. So our slope here, people are probably really tempted to put that 500 down, and you are super close if that's what you're thinking. But because it's going downhill, we're losing value. That would be a negative 500 there. The vertical intercept, so that's our starting price. So that new drill is 17,000. And then our equation, we're going to use that y equals mx plus b. So our equation here, let's see, is going to be, I'm going to go ahead and write this as y is equal to 17,000 minus 500x, okay, where y is the value and x is the number of years. So there's an example of kind of finding those parts to put together that equation from a word problem.